again. I'm here to talk to you today about mean, median and mode. These are the measurements that we use just to sort of furnish those different variables that we have to give you information on how they are spread, how the numbers are spread across the database. So the mean is tending to be the average value of all the data, which tends to be ranked. The median tends to be a really good indication of what's the middle line, what's the sort of the absolute middle line of your data. And then when we have non-numeric data, we can use something called a mode to be able to summarise that. And I'm just going to give you a very brief overview of how we calculate these and what that means really in practice. I'm going to use the usual sample, which is a classroom of 88 students, and how we can sort of fathom out what that data looks like in a histogram chart, and also how we can calculate mean, median and mode. Hope it's helpful. Okay, so just to be able to give you an example of how we calculate mean, median and mode, I've selected a dummy classroom, and this is a classroom full of post-registration students. We have 88 in total, and they're all in different age ranges. And what I'm going to try and identify to you is how those ages could be presented in a healthcare literature, for example, as either mean, median or mode, and I'm going to show you how we could calculate those. If you look at the table, you can start to look, we've got quite a few 45-year-olds when we look at the frequency column there. We have a number of 45-year-olds, and we have people ranging from all the way from 20 to 64. So that's instantly giving us an idea about our data and what does it mean. So when we're starting to explore our data and describe it in context, we get a picture that we've got 20 to 64-year-olds in the classroom. Most people look like they're around about 35 to 44, but we need to work out exactly what that is. Mean, median and mode will give us those quantifications of average, or what is the intended average. This is really important in healthcare research, because when you read some papers, they will tell you about they will give you a mean when perhaps they should be presenting the median. They'll give you the mode when perhaps they should be presenting the median. So it's how we balance up those statistics and how we look at how we sort of describe those statistics in the right way to give the reader the most accurate representation of the data that we're trying to present. So when we do start to collect any data in healthcare research or any research that we do, the first thing to do is start to really immerse ourselves in those data, to understand what's going on and to start to really identify what they mean in context. Mean, median, mode, and understanding the distribution and the frequency is really crucial to unpicking those data and to finding out what's going on. So you can see here what we've done. The first thing is to do the simple histogram, and that gives us an idea about what the graph looks like. So we plot on the x-axis the age ranges, on the y-axis the frequency of what's going on. That shows us, this particular chart shows us most of our students are in the age sort of 30, 40, 50 years old. And that gives us a really good idea. The nice bell-shaped curve is there. We don't have any skew to the left, to the under 20s. We don't have any skew to the right, to the over 60s. But we do have a nice gradual shaped curve. This isn't always the case. So for example, if we were taking data from research into something like gastroesophageal cancer, we would notice that an age range curve would skew to the right. So we'd have more people who are elderly with that particular condition. If we were looking at childhood leukemias, for example, the age ranges would skew to the left, and it would show that more younger aged people have childhood leukemia because of the nature of the illness. So when you're looking at any of these health data, always look at it in context. You guys are the experts in your practice. The first and the most fundamental thing to ask yourself is, does it actually make sense? So the next thing I'm going to do is just point out how we present the averages to you when we are writing theoretical papers and healthcare research papers. And that's how we present. We tend to use mean, median, mode, and a frequency distribution, just to try and explain what are going on in those data and to give you an idea about what might be happening. Okay, so the way that we calculate the mean is by adding up every single number for every single person in our data set. So we know person 1 is 20 years old, person 2 is 21 years old, person 3 may well be, whatever ages they are, we just add up every single age and we start to come up with a sum total of those ages. And then once we've done that, then we can divide by the amount of people that are in our range. So this is really important because it gives us that midline. It gives us what does that actually mean, and whereabouts does the middle sit in our data. Now the median gets us to grade every single number. So we'll have the 20, 21, 22, 23, 24, all the way up to the 64-year-old. And then what we do is we count systematically from the outside inwards to identify what is the central number. The mode gives us a different sort of analysis. The mode gives us how many times one number is most frequently cited in the data set. Now you can have two figures for mode. You could have different results because you may well get two numbers that occur most frequently in the data set at the same sort of levels. However, what the mode does, it gives us an idea about where the most frequently occurring number is in the data set. Once we've established what the mean value is, the standard deviation gives us how much the variables will differ from the mean value. And when you are plotting data and you start to think in graphs, you can start to think about what that looks like in context. Now, if you look at the three graphs underneath at the bottom of this slide, you can see we used the example earlier about a skew, if we were plotting ages, a skew towards the older age in something like gastroesophageal cancer, for example, where we're likely to see more patients suffering from gastroesophageal cancer as age advances. Now, if we did have that left skew of data and we had more elderly people than we had younger people, our mode would be slightly different. The most frequently occurring number would be those aged 65 or over, probably around about 70 for gastroesophageal cancer. But our median would be very, very different because we have so many more patients who are elderly than younger. Even more alarming is that our mean would be very, very different as well because the data are skewed. Now, when we have a nice normal distribution, which doesn't necessarily always happen in health, mean, median and mode tend to be quite similar. So one of the first things that you're always going to check with any health-related data is how similar are the mean, median and mode? Do your authors present all three? Or are they presenting mode when they're trying to suggest a skew in the data? Are they presenting mean when they're trying to suggest a skew in the data? Equally, you can see what happens with the right skew. So we talked about childhood leukemias, for example. If you're looking at something like childhood leukemias, your mode would be a lot smaller. You would have that sort of different skew and would be very different between the median and the mean. But again, your standard deviation, the differences between that mean value and the overall value would be really high. So if you start to see a standard deviation that's quite high, just start to be alerted, just start to think, okay, so what would those data look like if we planted them into a nice histogram graph? The next slide is going to talk to you about how we actually calculate the mean and the median and how we work that out and what that means in context. So in this slide, what I'm going to try and do is talk to you about calculating the mean, median and range, a little bit more detail. So to calculate the mean, what we're going to do is we're going to add up all of the variables in that one thing. So we're going to add up every single age of all of the students that are in our cohort. We have 88 students, so that's adding up all 88 ages. Adding up all of those 88 ages gives us a sum total of 3,506 years. So we know our classroom is 3,506 years old. That doesn't really mean anything in context. So what we do is we divide it by the number of people that are in our classroom, which is 88 people. This gives us that middle number, that mean, the average of ages in our class. And for this, 3,506 divided by 88 is 39.84. Now, 0.84 of an age means nothing really, so sometimes what you find when you're reading academic papers, you'll see that people will round that up or down, and you would probably round 39.84 to 40 years old. So a mean age of 40 years old is about approximately okay for our sample. Now, the median gives us a different sort of figure, and sometimes this gives us this shows us whether or not the data are skewed toward old or young or whatever variable it is that you're measuring. So the median, what we would do, we would order all of our variables from high to low or low to high, and we would count systematically from the outside all the way in to give us that middle number, that central tendency. Now, when we're looking at the range, what the range can do is it just gives us an idea about the spread of data. And what we're doing here is we start with the highest number, which is 64, and we subtract the lowest number from that, which is 20. So our highest age was 64, our lowest age was 20, giving us a range of around about 44 years old. This is really important because, for example, if in our classroom we only had 20 to 25-year-olds, our range would be very different. It would be in the 20s. So the range gives us a nice quick illustration of what the data looks like and appears. So I hope this whole session has given you some idea about how we calculate mean, median, range. I'm going to do some more discussions on standard deviations, on quantitative research methods, but I wanted to do these really quick, short versions and series to be able to help out.